Okay, the question is for the circuit in this figure here, obtain V1 and V2. Let's see here we have V1 and then V2, and we need to use nodal analysis. So what are the steps? So we will need some steps here. The first one will be label the nodes. Okay, the first one will be label the nodes and extract what informations that we can get from the circuits. Okay, and we already given that V1 is this node here. Okay, that is V1, and then V2 is this node here, and also we are given that this node is the reference node or the ground. So this symbol is a reference node, reference, or sometimes it's called ground node. And what does that is? That means that the voltage here P is equal to 0, right, relative to this circuit. Okay, and then the second step that we need to do is assume the direction of the current. Assume the currents direction for each component. Okay. Okay, let's see here. Maybe let's assume this is going down. Oh, maybe let's use another color. Red will be fine. This will be going down, and this one also going down, and this one is going down. This one may be going to the right, and for the branch with current source, I just follow the arrow of the current source. So this is going to the right, and this one will be going up here. Okay, and you can actually assume to the opposite direction we will have the same result but with a different sign. For example, if I get +3, you will get -3 if you assume the opposite direction. But be consistent for each solving circuit. So once you assume the direction, you stick with it. Don't change in the middle of the solving. Okay, and then the third step that we need to do is to do KCL, Kirchhoff current law, for each node. So we need to do KCL for each nodes. Okay, remember that we have two nodes here, V1 and V2. So we need to do KCL at node V1, and then we need to do KCL at node V2. Let's do exactly that. The first KCL that we need to do is KCL at node V1. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, let's see at node V1 here. Okay, and this is going out, this is going out, this is going out, and this is going out, right, from this node. All the currents are going out. So we will have 0 on the left hand side because there is no current that goes into node V1. Good. And then let's start by the easy one first. This 6 ampere current source, because we know exactly how much the current here, which is this 6 ampere. So we will have 6 here. Okay. And that is the easy one. But then for this 2 ohm resistor here, we need to calculate it using Ohm's law because this is not current but this is resistor, right? So we'll have plus, and how to calculate that? It is the node where the current comes from minus the node where the current goes to. So I'll have V1 minus V2, but that is voltage. To get current, we need to divide it by the resistance between them. So we will have 2 ohm here. So that is for this 2 ohm branch. Okay, we still have 2 more branches here, this one, and we can do same game here. For this current here, we will have P1 here, the current where it comes from, and then minus here the ground node, the current where the current goes to. So we'll have minus 0 here. divided by the resistance between them, which is 10. Good. And now the last one here, we will have this one here. So we'll have P1, where the current comes from, minus 0, where the current goes to, divided by the resistance between them, which is 5. Good. Now let's do some simple math here. Let's move this 6 to the left hand side. So I have minus 6. And then here we will have P1 minus V2 divided by 2. And then plus P1 over 10. And then plus P1 minus 0 is just P1 divided by 5. Now we can multiply both sides by 10, I think, to get rid all of the 2, 10, and 5 in the denominator, because they will cancel into 10, right? And on the left hand side, we will have minus 60, and then 2 and 10 will cancel into 5, so we'll have 5v1 minus 5v2, and then plus, we will have 10 and 10 will cancel each other, so we'll have v1, and then plus 5 and 10 will cancel into 2, so we'll have 2v1. Good. 5 plus 1 plus 2 is 8, so we'll have 8v1, and then minus 5v2, and that will equal to, let's move this minus 60 to the right hand side, so we'll have minus 60 here. Okay, and I think nothing further that we can do from the node V1. We have done this, and let's save this as equation number 1. Okay, and that is good. Now let's do KCL at node V2, but let's clean up the slide first. Okay, now we need to do KCL at the second node, which is V2. Okay, let's rewrite that. So we will have KCL at node V2. Okay, again, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, let's see here. We have 3 currents that goes in. This one, and this one here. Okay, let's start from the easy one. This branch here is 6 ampere. So we'll have 6. And then plus this branch here is 3 ampere. So we'll have 3. And then plus this branch here is V1, the current where it comes from, minus V2, the node where the current goes to. So we have V2 divided by the resistance between them, so we will have 2 here. Good, and the only current that goes out is this one, so we'll have V1, where the node where the current comes from, minus 0, because the current goes here to the ground, so we'll have 0 divided by 4. Good. Okay, now let's do simple math. 6 plus 3 is 9. So we have 9 plus V1 minus V2, then divided by 2. And then we will have V1 minus 0, that is V1, divided by 4. Okay, multiply both sides by 4 here. So we'll have 36, then plus 2 and 4 will cancel into 2, so we'll have 2V1 minus 2V2, and that will equal to V1. Okay, let's move this V1 to the left hand side, so we will have V1 minus 2V2, and that will equal to minus 36. Okay, nothing further that we can do, so we will have this as equation number 2. Okay, so now we will have 2 equations with 2 variables. We should be able to solve it, right? Okay, let's clean up this and solve the equation. Okay, we have 2 equations with 2 variables here, and I think the fastest way to solve it is by using calculator here, like this. And how to use this as equation solver, we set this up here, this button, and then equation solver is number 5. And because we have 2 variables, we need the first here. So we'll have number 1. Just plug in the coefficient. So we'll have 8 and then minus 5, and then the constant term is minus 60. Good. And then the second equation, we will have 1 and then minus 2 and then minus 36. Good. We will have our P1 here, which is 5 point, okay, 5 point, P1 is equal to 5.45, I think. Yeah, 45. And the unit will be in volt. And then what is V2? Okay, V2 is the Y value here, and that will be 20.72, then 73. And the unit here will be in volt. And I think that is the final answer for this question here, V1 and V2. So we get V1 here, and we also get the V2. The value of V1 is this one, and the value of V2 is this one. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.